Good morning, everyone, and welcome back again. Today, I want to start with a quick overview of what's going on for the remainder of this week. The first and most important thing to remember is that we have our midterm exam coming up on Wednesday. As I discussed on Friday, there are details about the exam posted to the course website. The exam will run for 24 hours from 9 a.m. on Wednesday morning through 9 a.m. on Thursday morning. One effect of the midterm exam is that for the people who have lab on Tuesday, normally the work for the Tuesday lab is due by 5 p.m. on Wednesday. But since we're taking the midterm on Wednesday, the Tuesday lab work this week won't be due until 5 p.m. on Friday, which is the usual time that the Thursday group will have their lab work due. And the lab this week focuses on arrays. It's going to be focusing on basic materials from arrays that we saw already from Chapter 7. And in the lecture today, I'm going ahead to Chapter 8, where the topic is still arrays, but starting today in Chapter 8, we're going to be looking at a variant of the arrays we've been looking at so far. Today, we're going to be studying what are called multi-dimensional arrays. All right, so let me start with the lecture materials for that. And then if there's some time left at the end of that portion of the lecture, at the end, we may say a little bit more about the exam and how to prepare for it. All right, so first of all, here is the basics of how you create an ordinary array. And the main thing to know about an ordinary array is you can sort of think of an ordinary array as being a list of data values. When you set up the array, you have to specify two things. One is what kind of data value you're talking about. In this example, it's basically a list of integers. And secondly, when you set up the array itself, you have to specify how large the list is, how many items it has. All right. Now, starting today, we're going to be looking at a variant of this basic construct. We're looking at a thing called a multi-dimensional array. And the simplest example of a multi-dimensional array is a two-dimensional array. And here is an example of how you would go about setting up a two-dimensional array. So the first thing to notice is that unlike an ordinary list or an ordinary array, which is set up with just a single set of braces after the variable name, for a multi-dimensional name, you can have two or more sets of braces after the variable name. And since the example we're looking at here is a two-dimensional array, it has both rows and columns. We set up two sets of square braces to indicate that this is a two-dimensional array. If you were going to set up a three-dimensional array, it would have three sets of square braces after the variable name. All right, then also you need to specify sizes. And since this is a two-dimensional array, which is basically going to be a grid of numbers instead of a list of numbers, we have to specify both how many rows the grid has and how many columns the grid has. The first number is always the number of rows, and the second number is always the number of columns. All right, so in this example, this is a two-dimensional grid of integers with 100 rows and 10 columns. And of course, in each separate example, you'll need to figure out exactly what data you're trying to represent. That will determine both the dimension of the array and the various sizes of the array. That all will come from some understanding of what data you're working with and exactly how you would need to organize that data to achieve the desired effect. Right now, here's the next thing to say about arrays, and that is typically when you go about writing code to deal with multi-dimensional arrays, what we've seen with ordinary arrays is that in most cases, when you write code that deals with an ordinary array, you're just going to write a single loop that is designed to go across that array and process the items in the array. Now, when you are dealing instead with a two-dimensional array, you're going to require a more complex loop structure to process all of the items in the array because you have to worry about both rows and columns. So when you're writing typical code that works with a two-dimensional array, you're typically going to need two loops. One loop that goes down the rows in the structure and another loop that goes across the columns in the structure. And here's a typical example. In this example, we're going to be setting up a table that basically stores a multiplication table. And it's going to have 10 rows and 10 columns. So we set it up initially with these sizes. And then to actually fill in the entries in the multiplication table, we will need a double loop structure. We need an outer loop that goes down the rows in the table, and we need an inner loop which for each row goes across all of the columns in that particular table. All right, then for each individual entry, we specify each entry in the table by specifying both a row number and a column number like this. And then here, since we're putting values into the table, we specify what each of those values is, and we assign it to the corresponding location in the two-dimensional grid of values. Right, and as always, the thing to remember anytime you're doing anything involving arrays in Java is that the numbering system that's used to number the rows and the columns, once again, is a zero-based numbering system. The first row in the structure is row 0, and the first column in the structure is column 0. And as always, you have to watch out for that zero-based numbering system. Okay, so let me pause here and ask if anybody has any questions about how to set up a two-dimensional array and also how this loop to provide values for the grid is working. Okay, so where we're going to go next is we're now going to pull out a series of examples. All three of the next examples that I'm going to be showing you come directly from the textbook. So I'm going to go through these examples in order from simplest to most complex. And in each one of these three examples, we're going to be dealing with a multi-dimensional array. All right, the first example we're going to look at is this closest points example. And to explain the purpose of this example, let me start by showing you a data file that this particular program is designed to read information from. So I've prepared a text file that has information in it. And this information is basically information about a collection of points in a plane. And each one of the points requires two pieces of data to describe its location. It requires both an x coordinate and the y coordinate. All right, so what we have here is a fairly long list of points. There's 1,000 points altogether. They're scattered all over the plane. And each one of these points, it has its location specified by giving an x coordinate and a y coordinate. All right, now, because each one of these points requires two pieces of data to describe its location and not one, we can't get away with just a single array here. It would be impossible to use an ordinary array of doubles to describe these 1,000 points because each point requires two pieces of information. Now, if we wanted to, we could use two simple arrays to store this information. We could put all of the x values in one array, and we could put all of the y values in another array, and that would be a valid approach. But since we're talking about multidimensional arrays, the approach we're going to take instead is to put all of this information into a two-dimensional array. We're basically going to represent this information as a grid with 1,000 rows and 2 columns, where the 2 columns represent the x and y coordinates of each point, and of course the 1,000 rows represent the 1,000 separate points. All right, so given that arrangement, here now is the Java code that is going to be working with this information. Okay, now the very first thing we're going to need is a method that handles the work of reading all of this data from the text file and putting it into an appropriate structure for use in the program. Right? And again, the choice that I made here was to represent this data using a two-dimensional array with 1,000 rows and 2 columns. And here is the basic setup needed to set up that two-dimensional array. And what we've written here is a piece of code that uses a scanner to read all of the data from the file, read the data values, put them into this array, and then finally return that array at the end of the reading process. Right? And one special thing you'll need to notice about the structure of this method is that since this method is going to be returning a two-dimensional array, that is going to affect the return type that we use. Right? So in the way that you indicate that you're returning a two-dimensional array of doubles is to use that notation, which specifies that you are specifically going to be returning a two-dimensional array of doubles from the method. Right, and then the code, the code for reading itself is pretty straightforward, because in each case we only have two data items that need to be read for each of the points. Instead of using a double loop structure, I'm just going to use a single loop structure where the outer loop goes down the rows of our data file, and then for each row in the data file, I'm going to just do two separate reads to read those two separate values. The first one will read the x coordinate of the point, and the second one reads the y coordinate of the point. And once all of that data has been read, we're going to return that array as the result of this method. Okay, now what we're actually going to be doing with all of this data is we're going to be answering a question. Since we essentially have 1,000 points that are scattered more or less at random around a plane, the question we'd like to answer is, of all these points, which two points are the closest? Right, and that's the main work of the program that we're about to look at. All right, so first of all, since we're talking about measuring closeness of points, one of the first things we're going to need is a way to measure the distance between 2 points. So here is a simple method that will take in the coordinates of a pair of points, basically in the form of 4 doubles, and compute the distance between those 2 points using the standard distance formula. All right, so that gives us some way of measuring the distance between points. So now we can work on figuring out which pair of points are the closest to each other. All right, and then most of the heavy work in this example takes place in the main method. In the main method, we're going to be calling the other method to read the points for us. And from that point forward, we're going to be working with this two-dimensional array named points. Okay, now the first thing we need to do is have some variables prepared that will help us to sort of track our progress as we go along here. And there are 3 main variables that we need to pay attention to. The first variable that is most important here is this one called shortest distance. And it is used to store the shortest distance between 2 points that we have seen so far. And then along with that shortest distance, we also will need to keep track of which 2 points gave us that shortest distance. So for that purpose, we have another pair of variables, P1 and P2. These are basically integer indices that point into the array and refer to a couple of points in the array. And at the beginning, before we have seen any points, what we're going to do is we're going to declare the first 2 points in the data set to be the closest points we've seen. So index P1 will point to point 0, and index P2 will point to point 1. And then we'll go ahead and compute the distance between those 2 points and declare that to be the shortest distance that we've seen so far. All right, so that takes care of initializing the variables that will track our progress as we go through the rest of the calculation. Okay, now what needs to happen next is we need to systematically look at all possible pairs of points in this collection of points. And to do that systematic search, we're going to have to use a double loop structure. The outer loop is basically going to work its way through every possible point in the data set. And the inner loop is going to pick a second point to compare against that first point. And so that we don't end up comparing pairs twice, this inner loop has a little bit of a slightly unusual structure. Instead of the inner loop starting at location 0, the inner loop will actually start at the location after the location the outer loop is looking at. The main reason for that logic is to guarantee that you look at each pair in the collection only once, and you don't sort of waste your time looking at pairs twice. Okay, so with that structure, that's exactly the loop structure that's needed to guarantee that we look at every possible pair of points. And each time we look at a pair, the first point we're going to be looking at is the point whose index value is I. And the second point we're going to be looking at is the point whose index value is J. And each time we look at a pair of points, the first thing we'll want to do is to compute the distance between them. And then we'll want to compare that distance against the shortest distance we've seen so far. And whenever we see a new distance which is better than the best we've seen so far, we'll want to record that as the new shortest distance. and also we'll want to record the index values of the 2 points that were responsible for giving us that. Right? And then when the double loop structure is completely done running, after we've had a chance to look at all possible pairs of points, we will have found the closest pair that's closest together. And the last thing to do is to print the details about where those points are actually located. Okay, so let's go ahead and run the example and see that it actually finds a pair of points that are reasonably close together. Again, the points in the data file are basically scattered around at random. And so here's what we get. It turns out that in that cloud of 1,000 points that are scattered around at random, there are 2 points that just by sheer luck landed very close to each other. They happen to have very close X and Y values. In fact, their X values are close and almost identical, and their Y values are also very close to each other. So obviously this is a pair of points that are very close together, and this looks like the winner. From among all possible pairs in this data set, these are the 2 points that happen to have landed extremely close to each other when we scattered the points around. All right, so that is the closest points example. And again, it's natural to use a 2-dimensional array in this example because every point is represented by 2 pieces of data. So if you have 1,000 points, each of which require 2 coordinates, you're going to require a 2-dimensional grid with 1,000 rows and 2 columns to represent that information. All right, so any questions about this example before we go on to the next example? Okay, now in the next example, we're going to be dealing with a completely different problem. So let's pull up the data file and the code for that next example. In the next example, what we're dealing with instead is answers to a quiz. The scenario here is that you have a group of students who've taken a quiz. It's a multiple choice quiz. The quiz has 10 questions with multiple choice answers possible. And what we have in this text file is a record of the answers that the students gave. There are 8 students. Each row represents answers given by one of the students, and each row has 10 entries in it, and these are the 10 answers that that particular student gave to that question. All right, so naturally, as you can see here, this data is organized into a grid. It's a 2-dimensional setup where the rows represent different students and the columns represent different questions that those students answered. All right, and the example that we're going to be looking at that comes from the textbook is basically that an example that goes through this data file and checks how many of the answers each of the students got correct. And it will basically print out a summary for each of the 8 students of exactly how many answers they got right. All right, so here now is the code for that example. Again, the first thing that we're going to need is, since the data file for this example is stored in a text file, we're going to need to start with a method that can read that data from the text file and put it in an appropriate array. Right? And since the data in this case is in the form of a collection of letters, what we're going to be setting up is a 2-dimensional array of characters. And the 2-dimensional array of characters has as many rows as there are students, and it has as many columns as there are answers to the quiz. And to give a little bit of flexibility here, I set this up so that both the number of students and the number of answers in the quiz can be passed in as parameters. So if you have a different setup in a later program where you need to read this data, you can change the number of students or change the number of answers, and everything here will automatically adjust itself to that. All right, so then the key thing here is to set up a 2-dimensional array of characters that has the right structure. It has as many rows as we have students, and it has as many columns as we have answers. All right, and then in this case, because it is very much a 2-dimensional grid of data that we're reading, to do the actual reading of the data, what we're going to have to do is set up a nested loop structure, which is very typical for working with 2-dimensional arrays. All right, and in the nested loop structure, we have an outer loop that works its way down the rows, and we have an inner loop that works its way across the columns using the appropriate structure for that. right? And then for each entry in the table, what we have to do is we have to read the corresponding character from the text file. And one small complication here is it turns out that the scanner class does not have a next character method that would read the next available character in the file. What it does have instead is it has a next method which will read the next available string. So basically what it will be doing is it will be reading the answers as strings instead of characters, but that's easy to fix because what we can do is we can take each string that it reads from the file and then immediately ask, well, what is the first character in that string? That's the letter that we actually wanted to read, and that will give us a letter that we can put into our two-dimensional array. Right, so then once we have read the data from the text file, we just have to go ahead and return that two-dimensional array as the result of that method. All right, and then here is the main part of the program. The next thing that we're going to need is we're going to need access to the correct answers for the quiz. That's actually coded into the program itself. We basically set up an explicit list of characters that is the correct answers to all of the questions. And then what we have to do is read all of the student answers and compare them against this set of keys that we've set up. All right, so here's what we do. Again, since we're working with a two-dimensional grid of data, it's going to require a nested loop structure with an outer loop and an inner loop. The outer loop is going to be working its way through the number of rows. The way that we're going to figure out how many rows that we have is by looking at our two-dimensional grid and first of all asking for the length of that grid. Whenever you ask for the length of a two-dimensional grid, what you're actually going to get back is the number of rows. So if you're writing a loop that is designed to work its way down those rows, this is the right structure for that loop. By using the length of the two-dimensional array to tell us how many rows we've got, that will go down exactly the right set of rows. All right, then for each row that we come to, each row represents a student, and what we want to do is get a count of how many answers they got right. All right, so for that, we need to set up a separate variable that will keep track of how many answers they got correct. And then we go into a loop that works its way across all of the answers that that particular student gave. The answers that are given by a particular student, those are accessible by doing this first. This gets you the row. And then if you ask for the length of that row, you're basically going to learn how many answers are there or how many columns are in that row. So then we set up a loop that works its way across the columns in that particular row. And for each answer we come to, the question is, does that answer match the corresponding thing in my list of correct answers? All right, so here's the if statement that will look at each answer given by a student and compare it with the corresponding correct answer that's in that keys array. And if those two things match, we'll want to increase the count of how many things that student got correct. All right, and then just before we finish processing a particular student, we'll have a print statement here that prints out the information for that student, giving both the student number and the count of how many answers they got correct. All right, so if we go ahead and run it, we'll see in the output pane a listing of all the different students and what they did on the quiz. All right, so, and unfortunately, since we've got this weird zero-based numbering system, it numbers the students in a slightly clunky way, but this is now the correct counts of how many answers each one of these students got right on the quiz. Okay, so again, a brief pause here for any questions about this example. Okay, well, we have a third example that I brought along today. And in the third example today, we're going to be dealing with a higher dimensional array. In this example, we're going to be dealing with a three-dimensional array. Now, arrays with more than 2 dimensions are quite rare in practice, but they do come up from time to time. In this example, how we managed to get ourselves into using a three-dimensional array is that we're going to be basically looking at a program that asks the user a series of questions. And each one of these questions that we're going to ask the user involves a grid of numbers. right? So the basic structure that we're working with here is a two-dimensional grid, but since we're going to be working with more than one grid, we actually have 5 grids that we're going to be working with here. You basically need a list of two-dimensional grids, which is going to require a three-dimensional structure to store all of that data. So that's why for this example, we're actually dealing with a three-dimensional grid of integers, right? And if you've been paying attention, something that you may notice here is that in all of the examples so far, when it came time to set up the braces, I always put the braces after the name of the variable. Well, it turns out you can do this in one of 2 ways. You can either put the braces after the variable name, or you can put the braces after the type. Both of these forms are legal in Java, and they both indicate that in this case, this is a three-dimensional array of integers. All right, and then in this case, instead of actually reading the data from a text file, the approach the author has chosen for this example is to actually type out the data values and use that to explicitly set up the three-dimensional array just by typing out the numbers in the three-dimensional array. All right, this is also a perfectly valid way to set up a multi-dimensional array. You can literally just type out the data that's in the array, and this will work just as well as reading the data from a file. Okay, now to explain what this example does, let me go ahead and run it for you. What's happening in this example is that the author is going to do a bit of a magic trick. The magic trick is to try and guess what day of the month your birthday falls on. All right, so let's pretend that today, which is October 12th, is my birthday. And let's run the program and see if the program can guess that my birthday is the 12th. All right, so let's go ahead and run it and see how it does this. Okay, so the way that the program works is it's going to show us a set of numbers 5 times. Each one of these sets is going to have different numbers in it. And each time the program shows us a set of numbers, it's going to ask, does your birthday appear as one of these numbers? And you have to answer either yes or no. You're going to enter 0 to answer no and 1 to answer yes. Okay, so in this example, since we're pretending that the 12th is my birthday and 12 does not appear in this first list, I'm going to enter 0 for that first list of numbers. All right, then it shows me a second set, and again asks, is your birthday somewhere in this set of numbers? All right, in this case, the 12th is not there, so I'll have to enter 0 again. All right, now it shows me another set of numbers. In this case, the 12th is there, so I'll enter 1 to indicate that it is in that set. And in the next set of numbers, the 12th also appears there, so I'll enter yes again. And then in the final set of numbers, it will ask me again, is the number in that set? And I enter no for this. And after I enter the final answer, it's going to come up with a guess for what day it thinks my birthday falls on. And what do you know? It manages to correctly guess the birthday based on that list of 5 questions that it asked. Okay, so in a minute, I'll explain how this actually works and how it actually manages to correctly guess the birthday involved. But first, let's take a quick look at the code and see how the code does the work of doing what we just saw there. Okay, so the main thing going on here is since the program needs to display a grid of numbers to me 5 times and ask for my input 5 times, first of all, there's a loop here that goes around exactly 5 times for each of the 5 sets of numbers the program is going to show. All right, and for each set of numbers, it's basically going to print a little message asking, is your birthday number in this set? And then it will have to print that set. And again, since each set is a rectangular grid of numbers, it uses a nested loop structure like this to print down 4 rows and across 4 columns, printing the numbers that come from the array that we set up earlier. So that prints the grid of numbers. And then last thing we have to do is prompt the user to enter either a 0 or 1, and we make a note of that. Right, now, here's a clue to how this process is actually working. What it's going to be watching when these answers come back in is that whenever you answer 1 to one of these questions, it's going to check for that situation. And in that case, it's going to be basically looking for a number in the grid of numbers, and it's going to be computing a running total. Right? And somehow magically, by adding up these numbers at the end of this process, it's going to be able to actually guess correctly what your birthday day actually is. All right? And it does that just by every time you answer one, it adds another number to this running total. And at the end, it turns out magically the running total is always equal to the day of your birthday. Right, rather amazing. And again, the fact that it can do this by asking only 5 questions is somewhat remarkable, but there actually is some mathematics behind this to explain how this actually works. And it turns out the trick to this is all based on binary numbering system. Essentially, what the program is trying to do is it's trying to determine what the binary representation of your birthday day is. All right, for example, the 12th, the number that we were using here, in decimal notation, the 12th is written as 12, but if you write the 12th in binary notation, it would be written in the form 01100. And again, the way that the binary numbering system works is that each place in the number corresponds to a power of 2. So this is the ones place, this is the 2's place, this is the 4's place, and this is the 8 place. And since the number 12 is basically the sum of 8 plus 4, it has a 1 in the 4's place, and it has a 1 in the 8's place and a 1 in the 4's place. Okay, now the trick here is that what the program is doing is it's asking you a series of questions, basically trying to determine what the digits in this number are. All right, and the way it's going to do this is the first set of numbers it shows you happen to be all numbers that have a 1 in the rightmost digit in the binary representation of the number. Right now, in this case, since I'm thinking of the number 12, and the number 12 has a 0 in that place, the number 12 doesn't show up in the list of numbers that have a 1 in that place. So I would have to say no in that case. In that case, the program knows that it needs to put a 0 in that location. All right, next we go to the 2's location. And what the program will show me is it will show me every number that has a 1 in the 2's place of the binary representation of that number. And again, it asks, is your number there? And if I say no, it basically learns that the number I'm thinking of has a 0 in the 2's location. All right, then it goes on to the 4's location. It shows me every number that has a 1 in the 4's location. And in this case, since I'm thinking of a number that has a 1 in that location, it will show up on this list, and I'll say yes. And at that point, the program will know that I'm thinking of a number that has a 1 in that location. All right, so by asking me a series of 5 questions, the program will be able to determine what each of the digits in the binary representation of that number look like. And once it's determined that, it will be able to guess correctly what that number is. All right, and the way that it actually guesses that number is that in each group, the first number in each group happens to be a number that has a 1 in the corresponding location and zeros in all of the other locations. So if you add up all the numbers where the user said yes, you get exactly the number the user is thinking of. So since I said yes here, it would take a 4. And since I said yes here, it would take an 8. So the final answer it would give would be 12, which is the correct answer. So basically by doing some tricks with binary numbering, it can always correctly guess what your birthday is just by asking you this sequence of 5 questions. Okay, so that is the very fancy guess my birthday example. And again, it makes essential use of a multidimensional array because we need to display this series of 5 grids to the user and ask them for each grid, is your number in that grid in order to operate the puzzle. Okay, so any questions about this example here? Okay, well, if not, those are the 3 examples that I wanted to show you today. One last order of business today is, since the midterm is coming up on Wednesday, I thought I would give folks one last chance to ask questions about that. In particular, I posted the study guide related to the midterm. Does anybody have any questions that they would like to ask about the sample problems that I posted here, or anything else related to the midterm exam? Does anybody have any questions about any of those things? Okay, well, if not, we're going to call it a day. We're going to finish a little bit early today. And then the lab this week is a lab covering just ordinary plain vanilla arrays. It'll be the first of two labs that we do related to arrays. And then, of course, come to the course website at 9 a.m. on Wednesday morning to get the problems for the exam. You'll have 24 hours to write up your solutions to those problems and send them in. And when I post the problems, they'll be posted with complete instructions about how you should be doing the exam and how you should be sending your results back to me when the exam is done. Okay, so I'll see some of you back again in lab on Tuesday. Again, there will not be a lecture on Wednesday because we're having the exam on Wednesday. So stay tuned for all of that stuff coming up in the rest of the week. All right, so long and have a good day until I see you all again.